Alright, so this is going to be your chapter 5 review for the test, which is going to be tomorrow. Is it recording? Red button there. Okay. Give the general expression for the value of $12,000 invested T years from now if its value increases at the rate of 6% per year. Okay, so first off, you're going to need a formula. I will not have the formulas on there. I think this is one of the two formulas you will need. Who remembers what this formula?
T-nod?
It is A nod. We'll start with A nod. Yep. And then 1 plus or minus, depending on if it's a growth or a decay.
12,000.
I'll put the numbers in later. This is the what? The rate. And then this is the T. Okay? And then this is A of T. Okay, so quick refresher. What's this value always going to be? The what?
Final.
Final. What's this value? Initial. What is this value? The rate. And what is this? The time. So if you don't know that, just to make sure you remember it. Alright, so let's fill in some information and see what we know. So what can I plug in right now?
12,000.
12,000 goes where?
Initial?
Initial, so it'd be 12,000. And then 1 what?
Plus.
Plus or minus.
Increases, so it'd be a what?
Plus
Plus what?
0.06.
0.06 to the
T.
Tth. Yep. And then it just, what does the question ask for me? Give what?
General.
General expression. Expression is not an equation, it's just an expression. So this is it, except I need to simplify. So how do I simplify that?
12, parentheses,
Yep, so
1.06.
12,000. 1 plus Sorry,
Not
1.
plus 0.06.
106 to the
T.
T. Okay, and that's all you would do in that problem. So you're not solving on that. Questions on that? Alright, next one. So let's simplify the directions here. Now, you have a calculator. So for some parts it might be best to check them like that. But what could I do for power rules here? So let's think about the rules for exponents. If I multiply the same base,
You add.
you do what to the exponents you said?
Add.
You add. So now it's 2 to the 4th over 2 squared. Now what am I doing with the same base here?
Subtracting.
Subtracting. So now you're going to subtract these two. And what does that put me at? 2 to the squared, which is actually
4.
4. Okay, this one's an easier one. This one's a little more difficult. Why is that one more difficult, the second one? That plus sign right here, yep. Okay, what do we know here about this? That would be turning into 1, right? So technically I have 1 plus. Okay, we gotta remember some rules for exponents. What do we know about a negative exponent? What does it do?
Goes to the bottom.
Flips it, so now it's what, 1 over 3 to the 3rd? What can you simplify from this step? 3 to the 3rd, what's that turn into? So I got 1 plus 1 over 27 to the negative 1. Okay, again, I cannot distribute the negative 1 in there because of that what? Plus sign. If this is a multiplication, then go ahead and distribute that negative 1, but it's not. Okay? Now, how do I combine fractions here?
Add 27 to
Common
1.
denominator, right? What would the common denominator be here?
27.
So what would I put on the bottom of here? 27 and,
27.
so what would that actually be now? 28 over 27. Again, if you had a calculator, could I not plug in 1 plus 1 over 27 and hit math fraction?
Yeah.
Yep. Okay, it'd be this to the negative 1. Again, what's the negative exponent mean I'm going to do? Flip it. Okay, so now what's my answer going to be then?
27, 28.
Yep. And I'm done. Questions on that one? Alrighty. Next one. So again, if I don't use a calculator, I always gotta think what? Same base. So if I look up here, 8 and 2, can I think same base?
Yeah.
Yep. Let's do this first. What does this guy turn into? Okay, let's change him right away. So square root is the half power. Okay, and then I'll work on the inside right now. If 2 is my base, do I need to change this one on the bottom?
No.
Nope. Let's do the top though. So what would 8 turn into?
Cube.
So 8 is gonna turn into 2 cubed to the what power still?
4.
To the 4. Okay, what do you have up here right now? Power to power, you see that right here? So what would that turn into now here? 2 to the 12 over 2 to the negative 3 to the half. PEMDA says we still want to simplify inside. Yeah, so flip.
What's
So now, yeah, so if you want to, okay, if you like to flip stuff, you could move this guy where? Up, and there'd be 3 more of those 2's on top, which would get me to how many 2's altogether on top? 15, okay? Or, if we use our rules, what's the rules if you divide the same base? Subtract. So what's 12 minus a negative? Minus a negative turns into what?
15.
You see how it also gets me to 2 to the 15th? And then how could I finish this? Simplified, power to a power, and what does that give me? 2 to the 15 halves, or 7.5 if you want, yep. And you can leave this one because that doesn't come out nicely. Questions on that one?
What happened to the second 2?
Which one here?
Yeah.
So when you combine, if you divide the same bases, it turns into 1?
You're doing both.
Yep, or if you, like on that last problem here, if I multiply, right up here, if I multiply the same base, you see how these 2 2's turn into just 1, and then you add the exponents. It's kind of like logarithms. If you have 2 of them and you're combining them, it turns into 1. It's the same rules with exponents. Okay? What's not so nice about this problem over here on this side? A plus sign, yes. The reason that's not very nice is because now you can't just swing things up and down and move them around. What could I think first though? Could I think same base again?
Yeah.
Okay, let's do same base first. It'd be what then? Here, 3 to the negative 2 plus
3 squared
3 squared to
to
the,
the negative 3rd
yep,
over 3.
over 3 to the negative 4th.
3 to the something.
So what do I have now next that I could do up here? Power to the power right there. And what does that give me?
Negative
3. What do you do with power to power? We
Combine.
multiply, so it's negative 6
negative 6
to the, and then 3 to the negative 4.
to
Okay, there's 2 ways to do this. One way is hard, one way is easy.
the. You combine.
Okay, if I wanted to combine these, I'd have to first convert them to fractions, find a common denominator, put them together, figure out this is a fraction, now you got a fraction divided by fraction, and you flip it. You wanna do that?
No.
Okay,
Yes.
some may not. Could I also just split this into 2 separate fractions?
Yes.
Yep, that's the easier way on this one. So it would be 3 to the negative 2 over 3 to the negative 4, and then 3 to the negative 6 over 3 to the negative 4. So when I split that into 2 separate fractions. Okay? And then from here, if you like to flip things around and move them, what could I now do? Could I move this to the top and this to the bottom?
Yeah.
So it'd be no, because negative exponents mean I can flip it from top to bottom. And there's nothing else in there.
And 3 squared.
Over 3 squared plus, and then you can do the same thing here, so move this up and this down. So it's 3 to the 4th on top, and it's 3 to the,
You can't just subtract it?
What do you mean by subtract?
Like negative
So yes,
2.
yep, so if you wanna use the rules, we can subtract them too. So if you wanna use the rules, it would be -2 minus a -4, which turns into a +4, which would end up as what?
2.
2, so it'd be 3 squared then, right? And then if you did that rule here where you divide the same base and I subtract them, 2 negative make a positive there, so it'd be -6 +4, which gives me +3 to the -2. Or if you look over here, I'm kind of splitting this problem two different ways, depending if you like to move them, or if you just use the rules. Okay, here what happens, these two cancels, you cancel out 2, how many are left on top?
2.
So you see that's 3 squared. And then here, if I cancel out 4 here, I can cancel out 4 there. And I'm left with how many on the bottom?
Negative.
2. Now notice that's on the bottom, and wouldn't that make sense
Oh.
here?
Oh, that is
Because isn't 3 to the -2 mean it goes to the bottom? Alright, so now again, it's the same problem both ways, because now do you see how it's 3 squared plus, again, negative exponent would be 1 over 3 squared, so now we're at the same spot. So now all I need to do is just simplify and combine the fraction. What's 3 squared?
9.
9, and then plus
1/9.
1/9. So 9 and 1/9, or if you combine it into one thing, it would be 9 times 9 here, which is what? 81 plus 1 more would be what? 82 over 9. And that would be my answer.
How would you get 82?
If you change this here, it'd be 9 times, I'm changing this mixed fraction into an improper fraction. So 9 times 9 is 81, and then you add that 81 to the 1 to get 82. Again, if you also just in your calculator went 9 plus 1 divided by 9 and hit enter, and then math fraction, that'll get me to the same spot. Does that answer your question? Okay, anyone have any other questions on this one? Alrighty, next problem. Alright, so there'll be a problem like this that says to solve. Okay, so if I'm gonna solve this, what might be my first thought process?
Move the 4.
Same base, yes. Okay, so you're either gonna use same base on the test to solve them. Notice, where's the x located? In the exponent. Whenever it's in the exponent, it's either gotta be same base or it's gotta be logarithms. And on this problem, these are nice same bases. So let's do same base. I'll let you guys try that right now quick. So think about 4 and 64. Is 4 a base of 64?
Yep.
It is, isn't it? So you could turn this to a base of 4, turn this to a base of 4, or you can make them both base 2, and you get the same answer at the end. I'll go base 4 up here. That's what I'm gonna do. That way I don't have to change the left side, it stays. Is it 4 to the 3rd power?
Yep.
Okay. So now I'm here, what would you do to simplify now? Combine by what? Power
Power.
to a power? So what would that turn into here?
9 minus 3.
Yep, so 9 minus 3x here, and it's 4 to that. And then 4 to this. And what is the rule? If the bases are equal,
Exponents are equal.
exponent's gotta be equal, so technically you can just rewrite a new equation. So 6 minus 2x equals 9 minus 3x. Okay? And then using algebra, what do I move first? Oh.
X.
I'll add this 3x over to get the positive to this side. And then I'm gonna subtract my 6. So then that cancels, so I get what here? I get
What?
x equals 3. How could you know if you got the right answer on the test?
Plug it in.
Plug it in, right? So let's, so 3 times 2 is what? 6. 6 minus 6 is 0, okay, and then anything to the 0 power would be 1. And if I plug in a 3 here, what's 3 minus 3? 0. And anything to the 0 power turns into
One.
1, yep, so this is my answer. Any questions? Alright. Next question here. Using that same formula that I gave you on the first slide. A gallon of milk costs $3.29 2 years ago. Now it costs $3.98. To the nearest percent, what has been the annual rate of increase in its cost? So using that same formula,
Junior high speech meet kids, you're dismissed at this time. Junior high speech meet. Thank you.
okay. So up here, what would be my initial amount or my starting amount?
329.
Okay, so depending on where you want to think about it, you could do that. Okay, it'll work. So if you did $3.29, that would be 2 years ago, right? So it started at $3.29. 1 plus, we don't know the rate, 2 up here, right? So you gotta think about if you're on a timeline, if you started at $3.29, you're going in the future 2 years, so that's why it's positive. Okay, if you started right here,
It has to equal,
what? So if I started with this amount, that's today's, you would be going backwards in time, so if this number was my initial amount, 398, this would have to be a -2 because you're going backwards in time by 2 years. Okay? If this is my initial amount and I went ahead 2 years, what's my final amount after 2 years later?
398.
398, that's my final again. Alright? How would I solve a problem like this then? What's farthest away from the variable on the same side?
3.
$3.29. What's happening to that? It's being what? How would you get rid of multiplication? Division, yep. And what you do to one side, you do to the other. I don't know that as a decimal, so you need a calculator. And you can tell me what it is. So it's 1 point something. Give me one more decimal.
It's 209.
We'll go 209 then. Okay, and then equals 1 plus r squared. So now what's the next thing I want to get rid of?
That was parentheses.
The parentheses. So I want to get rid of the square. What is the opposite, or how do I get rid of a square? There's 2 ways. So square root, because if you know that it's a square, the opposite would be square root. And you are also right back there, the reciprocal. I'm going to do the reciprocal power, just so you know how to get rid of that. But what you do to one side, you got to do to the other. So now on your calculator, please, give me 1.209 raised to the 1/2. Which, yes, the half is the same as the square root.
1.099.
1.099?
I just want me to round it.
That's fine. Okay, we'll probably round at the end here. And then, now what's this here when you do power to a power?
Cancels.
Cancels and turns into 1, right? So now you have 1 plus r. How do I finish this problem?
Minus the 1.
Minus the 1, and I get 0.099 equals r. So the question was, what is the annual rate of increase?
Gotta move the decimal point.
Twice, it's what, 9.9%.
Percent.
Questions on that? Everyone's checking these on your calculators, so we're making sure that we're videoing the right answers.
Yeah,
I was thinking, what if the answer is wrong?
is this a really good study guide?
Not really good, but it's good. Not really good, no. Okay, any other question on this one? Alright, next one.
Are we gonna finish this up tomorrow?
No, we'll finish it today. Suppose that $1,000 is invested at an interest rate of 8.5%. How much of the investment is worth? How much is the investment worth after 3 years if compounded continuously? Okay. What on this one? When you guys see the word continuously, it is this formula: PE raised to the RT. That's the other formula that you will have to have memorized for the test.
It's just those two though, right?
Yep, those two are the only ones I need to have for the test. Okay, so the word continuously, you're gonna use this, otherwise you're gonna use, this formula. A naught, 1 plus the rate or minus the rate of time. Okay, P, again, is the principal balance, or the principal amount, or you can say the initial amount if you wanna put the, P naught. You don't need that right now. Okay, so suppose $1,000 is invested, where would the $1,000 go?
P.
P, yep. What's my rate?
8.5.
Is that all right, 8.5?
Well, 1 point.
Points
So
085.
0.85, you will have to remember to convert it, we always convert the percent to a decimal. And then how long? 3. This one's nice, we just take it in my calculator like that.
Punch it all in.
Punch it all in, so if I'm plugging in my calculator, I would plug it in. Where do I go, 1,000. Second division sign is the E, actually you can just go second ln,
1290.
and then 0.085 times 3. And 1290, so $1,290.46. And that would be my value for that one. Questions on that? Alright, next one. Alright, find the exact value. So what do I do first here? Push,
Push
yep,
and pump.
push and pump, yep, so if there's, I've set it equal to X, and we take the 3, and to get rid of this log, you do what? You push it over, pump it up, and the log
Disappear.
disappears. So now I'd be left with what, 81 equals
3 to the X.
3 to the X, and now I gotta think what? Same base.
No.
So what's 81 turn into? 3 to the 4th equals 3 to the X. So what's my answer? 4. Question on that one? Alright, now I got a problem like this. Express y as a function of x. Alrighty, so what I need to do is I need to simplify the sides so that I have the logs combined or looking better on each side. So right now, I can't divide yet or get rid of the logs yet because of this 3 out in front.
Oh, yeah, you gotta put that in the exponent.
Yes, so this 3, whenever there's something in front of the logs, always moves where according to the law number 4.
Back of the bus.
Yep, and on top as a power. So I got log base 2 of y equals that, and then 3 to the x squared to the cube.
Now you can divide?
It's technically not dividing, it would be I'd raise this side to a 2, and then I'd raise this side too, because you see how it's a log on this side and it's a log on this side? Okay, and what happens when the log and the base 2 match up here? They cancel, and what happens here? They cancel. And I can actually distribute here. So what would this turn into here? 3 to the what power? 3 to the 3rd, and then it'd be x squared to the 3rd. What's 3 to the 3rd?
27.
So 27, power to the power, x to the 6th. Have I expressed y, so is y by itself, in terms of, or as a function of x? Yes. Alright, next problem. So here, the problem is this 3 is actually in front of the log. I can't take this 3, move it up, because it wouldn't work like that. So what I actually do on this one is I'd probably want to get the logs on the same side, so I can combine them. So what can I do here to combine the logs to the same side?
Yeah, those 1 over.
I could plus the whole log of 2x to the other side, right? That would go away. I'll write it out here first so you can see what it would be. So log base 2 of y plus log base 2 of x equals 3. What is the rules for logarithms if I'm taking two logs that are adding together and I wanna combine them into one log? So when I combine the logs, if you add, you what? Multiply. So now do you see how I'm combining the logs into one log, base 2? And they're the same base, so we can do this. And then if you multiply, what am I multiplying? Y times x. Okay? And now, what could I do?
You need to do logarithms.
How would I do that?
Push it to the other side.
Push to the other side and pump it up, right? And what happens when you swing that over? Log cancels and it's y times x equals 2 to the third. And I'm trying to do what here? I'm trying to express y. So I want to get y by itself, divide by x. So then y equals, what's 2 to the third? 8 over x, sorry, yep. So then y would equal 8 over x. Questions on that? Good. Okay, next one, right? In log base b m and log base b of n. So I'm splitting them up into logs. One of them has an m in them, one has an n. So on that last problems, we took the logs, like down here, we combined them. But on here now, we're trying to separate them. What can I do first on this first one?
Get rid of that fourth.
Yep, let's change this guy right here. So what does that change into?
1/4.
1/4, yep, power over root, so be log base b of m cubed times n to the 8th to the 1/4. What's the next thing I could do? Distribute because it's timesing, yep. And that's power to a power. So now I have m to the 3/4 times n to the 8/4, which actually that will turn into 2. Alright, so now what could I do if I'm trying to split them into two separate logs? How many parts are being multiplied here? There's 2 parts, right?
Yeah.
What happens when you multiply? When you separate them, it turns into adding. So how would I write it? Log of b of m to the 3/4 plus
Log B.
log base b of n squared.
Do we have to have those B's?
They're supposed to be there. I'm probably not gonna mark it wrong if you don't, but yep. I don't know if they're on the test or not. What's the final step? Law number 4. Exponents move where?
Oh, yeah.
Okay, remember to do that on the test. That's a mistake sometimes students will forget about. Okay, so then what's my actual answer? 3/4 log of m plus 2 log base b of n. Questions on that? I'm not done writing. Good? Alright, and the second problem here. So again, I'm splitting, so the directions again say write in log of m and log of n. So not together, m and n, separately, m and n. So how would I separate these m's and n's now? A division turns into what? Subtraction. So log of m squared, now it's minus log of n cubed, and then what?
You put the exponent front.
Yep, bring them on front, so it's 2 log m minus 3 log of n.
Forgot your B.
I did.
It just says